The instructors there at that time used to inject a fault in one of the systems, like DS-22 or a radar. And this used to be done at 8 o'clock. The whole class, we were about 15, 16 people, were told, go inside, now resolve the problem. And this to lock us inside till 8 o'clock in the night. So whenever you finish, you can come out. If you don't finish, 8 o'clock only the door will open. I read an article recently about a smart ship concept for in the US Navy. INS Surat, which was commissioned on 15th of January, is called a smart ship because inside they made smart suites, and which the AI part has been done by Inikai. This is not now when Make in India has become a buzzword and popular. We have been doing it for the last 30, 40 years. We have been designing our own ships, right from Ajay, that was in 1960, to the aircraft carrier, INS Vikrant. And, on 15th of January, we commissioned 3 ships on one day. So it's always a fight between a submarine and the warship. Who finds whom first? It's like if you're inside a room and you're in a mosquito net, and there's a mosquito inside. The mosquito is the submarine and you are the warship. Okay. Now your job is to catch the submarine. And submarine is that mosquito which has dengue. So once he bites you, you have it.
Hi everyone, all my viewers are welcome to the channel. My name is Adip Kundra and this is my 7th vlog. Today's episode is going to be very special to me because we have a very esteemed guest. Esteemed because he served in the Navy for nearly 40 years. During his period of the service, he was known as the senior most technical officer of the Indian Navy. He's an alumnus of the National Defence Academy, passed out in the 65 course. He did his NDC. Before that, he also did his MTech from IIT Delhi. I've known him since I was a trainee officer at INS Wellington, which is a training establishment at Gujarat. Then I've seen him as the Chief Staff Officer Technical at Headquarters Western Naval Command, the Director General Naval Projects at Mumbai, and eventually by the time he retired, he was the Chief of Materiel. So many of you who are from the Navy must have already guessed his name. He is none other than Vice Admiral Sandeep Naithani. And without wasting much time, let's jump on to the interview with the Admiral. So dear audience, today we have a very special and an esteemed guest with us. That is Vice Admiral Sandeep Naithani, Param Vishish Seva Medal, Ati Vishish Seva Medal and Vishish Seva Medal. Sir, good morning and welcome to the channel.
Yeah, good morning to the audience too. And this is the first time I'm coming to your channel. And I know you from quite some time, so it's quite an honor and privilege to be there.
Sir, the privilege is totally mine, sir. Because primarily because of 2 reasons. Because I've always cherished working under you, sir. And whenever I got the opportunity to work under you, there's one thing that I learned. That is keep innovating. And that is what the theme for today's vlog is. We actually want to learn a lot about the technology that is advancing in the Indian Navy and how it has spanned throughout the years of your service. But before we come to the main content of the video, sir, I came across this picture of yours where probably you were holding the appointment of the Director General Naval Projects at Mumbai, that is the naval dockyard there, and you were cycling across in your uniform in the dockyard. So, sir, what was your mindset that day? Why did you ditch the flag car that day?
That was a different actually experience. When I was the Chief of Materiel, besides looking after technology, we also look after green initiatives.
Okay.
So this was one initiative across the dockyards of the Navy where we introduced e-bikes. Okay. As you are aware, we love cycling. We have cycled about 60 kilometers, 70 kilometers all around. And but e-bikes was one where we wanted the workers to move around in e-bikes. It was environmentally friendly also, and it would have eased the transportation requirement in the yards. So this was one e-bike which they had introduced. So I was trying it out. That's why I was in uniform, and it was a nice experience.
Great, sir. So a very creative way of promoting sustainability within the dockyard and easing out the commuting options for our people out there as well. I really appreciate that, sir. That brings to my first question, sir. I would be referring to some of my notes because I had to go through so many pages to understand the kind of versatile and rich experience that you have, sir. So, having served for more than 3 decades as a technical officer in the Indian Navy, sir, you would have certainly witnessed a lot of advancements in technology in use by the Navy. So, we would like to certainly listen to your experience with regards to the same.
So I joined the Navy in 1984 as a cadet first for 6 months, and so totally I served in the Navy for 40 years. And before that, 3 years NDA. So it was a great experience. But if we talk about technology in the Navy, generally we think only about weapons and sensors. It is actually much more. First of all, as you know, we are a three-dimensional Navy. We have aircrafts, we have warships, and we also have submarines. So delving into technology of each is very cumbersome and it'll take more time. So we'll just concentrate on warships and also a little bit about submarines. As far as warships are concerned, again, it's not only electrical weapons. When you become the chief of materiel or go higher up in the ladder as a technical officer, you have to deal with all types of technology. You can divide it into three. One is float, move, and fight. If you divide these into three sections, float means anything to do with the basic hull structure. So that is the steel, what steel or what metal is used. Then after that, what paint is used. Then there are stealth technologies. All this comes under the float component. In that also we have made a lot of progress. We have had different hull configurations. And as you know, we have a director of naval design. We have been designing our own ships right from Ajay, that was in 1960, to the aircraft carrier INS Vikrant. And you know, on 15th of January, we commissioned 3 ships on one day. That is 115 Bravo, that is Surat, 117 Alpha, which is Nilgiri, and third was a submarine of Scorpion class, that was Vakshir. So that all Indianization effort comes in the development of hull. So also earlier, what used to happen is we used to have because you know the seawater environment is very corrosive intensive, so it spoils the hull. So we have 7 coats of paint which is put on the hull because there are also bioorganisms which stick to the hull. And we have now developed our own paints, and the latest paints have come in. Now there are only 3 coats required. The steel is better, so the corrosion also now we know how we have a handle on it. So that is as far as hull is concerned. That is the float component. Next we come to the move component. Move component again is huge. That is propulsion. Then you can come to power generation. You can come to air conditioning, HP air compressors. It's huge. And what has happened over the years is that we have developed. We used to have steam propulsion. We used to have diesels. Then came gas turbines. Now we are generally stabilized into gas turbines. The gas turbines give us flexibility of economizing on the fuel and also going at fast speeds. Here also, one more thing which generally we do as a technical officer in the Navy, that we have been promoting Indianization. And this is not now when Make in India has become a buzzword and popular. We have been doing it for the last 30, 40 years. And that is another topic which we can discuss at some other time. But as far as propulsion is concerned, the basic improvements or innovation which is happening now is on the controls. So how do you do it? Now we have an integrated platform management system. Even what happens is that in case a torpedo hits a ship and it floods on one side. So earlier we used to calculate and see where should we flood, which compartment should we flood on the other side so that the ship becomes stable again. Now we have a system called Battle Damage Control System, BDCS, which automatically calculates immediately. So we know what to flood, what to plug, all these things. Again, they're all control systems, they're auxiliary control systems, and that has become more and more advanced with the PLCs coming in, microcontrollers coming in, and new software. Last part is the fight. Fight component is, again, there are subdivisions. The basic thing is navigation. Navigation, because I'm an electrical officer, I was more concerned about this and some part throughout my life. So when we were young and in the initial stages, when our this is around the 80s, the gyros were huge. Gyros, I don't know how whether you know about the gyros. Gyros used to be big three-dimensional spinning machines, and they used to spin at very fast rates. And there was a property called precision. And if you can Google about it, and because of that, we could always point to the north. And that is how the gyros were earlier. They were huge, bulky items. Then later on, when I was in Virat, the items became smaller. They were Mark 23. They were generally from Anschutz or Perry. There were two companies. Now there are ring laser gyros. I've seen the innovation now. Now you see ring laser gyros where two beams of laser go in opposite directions, and that's how it becomes stable. We also now have fiber optic gyros. That's how we are going further, because that is the most important thing. We should know which direction we are going, and based on that, we decide on our position. Where are we? Now we have the GPS. We did not have the GPS earlier. So when GPS was not there, we used to have the sextants. We used to also find out the relative wind. There was something called the Battenberg. These all are archaic terms now, but all of you can Google and find out how was navigation done in the older times. But there's always a threat that there may be a time of GPS denial. So we may have to go back to our basics. We know that if electricity is not there, how to use a candle and how to work out. It is the same way. We are always prepared for that eventuality also. The sextant is one where we can navigate through the star sites. You see the stars, and based on that, we used to navigate. So that is how we have progressed as far as gyros are concerned. It was very interesting when we were in Valsura. The system was very complex. We used to have switches, relays, contacts, and the diagrams used to be for the full room. We used to just lay down the whole chart and do the troubleshooting. You have not faced it in Valsura, but when I was in Valsura, there's a school called Electrical Equipment School. But what used to happen is the instructors there at that time used to inject a fault in one of the systems, like DS22 or a radar. And this used to be done at 8 o'clock. The whole class, we were about 15, 16 people, were told, go inside, now resolve the problem. And this to lock us inside till 8 o'clock in the night. So whenever you finish, you can come out. If you don't finish, 8 o'clock only the door will open.
Okay.
So that was one great challenge we used to have. We used to also, this was, I think, once a month in our that last equipment phase. We used to keep, and it was not easy because one contact, then we used to trace the circuit. We have to see where the current is going, why the current is stopping, and what is happening, where the fault injected. So interesting times. That taught us logic. How do you trace and this? Because nowadays they're all PCBs. It's very difficult to trace anything. Everything goes into a machine or a tester, and then it comes out. The result comes out. But earlier we used to do it physically, then find out that a relay is jammed, to change the relay, or some spring is gone. So finally they were all mechanical parts, or there's some carbon in the contacts, and that's how you to resolve. So that's how from that we have come now to all PCBs, multi-layered PCBs, etc. So that is the radars. Radars now what we have. So earlier there was the transmitter, then the receiver. There were two different parts. Now we have got something called TR cells. They're transmit receive cells and TRG modules. So if you know, we have the latest radar, the MF Star radar, which is a collaboration with Israel, and that with IAI. We have it on our 15 Alpha, that is the Kolkata class. We have 15 Bravo, the Visakhapatnam class, and now 17 Alpha. Also we have it on Vikrant. And they have TR cells. So the transmit receive cells are, and they're made of one material called gallium arsenide, or now it's gallium nitrate. And so that the losses are not there. Because what used to happen is after transmitter, when the receiver is down below, when it's coming down, there used to be losses. Now it's the TR cells are right on top. They're all solid state. They don't have to rotate. So things have changed as far as the radar technology is concerned. Coming to sonars, I don't know whether you heard of Commodore Arogya Swami Paul Raj. So he's ex-NDA like us. He was he did MTech from IIT Delhi. I also have done MTech from IIT Delhi, because IIT Delhi is one place where they specialized in underwater electronics and sonars. So we all did MTech that time. And in the 1971 war, we lost Kukri, and Kukri was lost to a Pakistani submarine. So what we realized is that the sonars which we bought from other countries, they did not work well here, because our waters here in the Indian Ocean around us are warmer than the waters in European countries or in Russia. So then there was no other way but to design our own sonars. So Commodore Paul Raj was asked to get into this. He had done his MTech. Then we also sent him for a PhD to Stanford. He was in NPL as a scientist, and he designed a sonar with his own team. That sonar was APSO. That was the first sonar. And later on, now we have the latest version of it. We have different, we have for submarines, we have Ushush, we have Hamsa, we have different types of sonars now based on that original sonar, which were designed by Commodore Paul Raj. And you can again Google about Commodore Paul Raj. He is now a professor emeritus in Stanford, and he is the father of MIMO. The Wi-Fi which you use on your mobiles are thanks to him. So he's won many prizes. So he's another one which is a revered person, and right now the nation is looking up to him to see that we get into the semiconductor manufacturing bus. So he's helping us in that regard. That is as far as sonars are concerned. Communication also, we have come a long way. Electronic warfare again is another thing which, and all this we have done it in the Navy because we have an organization called VSI. And VSI, this came in because VSI, we made this organization because when we had ships originally only from UK, the older ships were from there. Even earlier, INS Vikrant and INS Virat, the earlier ones, both were old ships from UK, and then we refurbished them, and again they became Indian ships. So, and we also then later on got some ships from Russia. So our equipment was all mixed. There was Russian equipment, there was Western equipment, and then we started Indianizing equipment. So there were always interface issues. So then we made one organization called, that time it was called VESO, now it's called VESI, which is a weapon engineering establishment which did all these interfaces. And now it has grown multifold, and we are doing wonderful, they are doing wonderful work now. They are doing on cyber security, they are doing on combat management systems. Whatever you can think of, the cutting edge technology, they are there. And that is how we are built up. So what was VESI's role was develop the initial system, then hand over to either a public sector industry or a private industry, and then he takes over from there. So we have been handholding people because we are not manufacturers. We can only help them in the initial design and what we want. Now we come to the weapons. Weapons again, we had for the submarines, that we used to drop depth charges. What happened in the submarine? Submarine is very difficult to find out where a submarine is. I'll give you an analogy. So it's always a fight between a submarine and the warship. Who finds whom first? It's like if you are inside a room and you're in a mosquito net, and there's a mosquito inside. The mosquito is the submarine and you are the warship. Now your job is to catch the submarine. And submarine is that mosquito which has dengue. So once he bites you, you had it. So both ways it is there. So it is good fun. And what happens is, suppose the light is off. So what is given is that we have a sonar. The sonar, so inside the mosquito net, we give you a torch. Now with the torch, you can keep looking for it. You may just sight it once, but again it goes off. You can hear the buzzing sound. So what do? So what we used to do earlier is that start clapping. If a mosquito comes inside, it's gone. Similarly, what we used to do earlier was we used to throw depth charges down the room. The depth charges were there, they used to blast. And if the submarine somewhere lurking around it with the compression, it used to blast. So this is an analogy with how the fight between a submarine and a warship happens. But now we have more sophisticated sonars. We can find it. They also have become more stealthy. We can't find out where a submarine is. It keeps hitting very quietly. You must have seen some war movies on that. So it's very interesting. So sonars are very, very important. And for submarines, there are different things. They have to be silent. When they come up, the propulsion, the battery should be such that they don't have to come up very often. So we have gone to nuclear submarines also. So that's another field which we can discuss later. Then we have guns. Now we have indigenized guns. Generally, one SRGM made by BHEL has been standardized in all the ships. Missiles are another thing which generally we have been buying from abroad for quite some time, but now DRDO has made some missiles for us. They're still designing it, but we know you must be aware that BrahMos is one standardized surface-to-surface missile which we have now inducted.
Yes.
So we can keep going on, but technology is very, very interesting. As far as the latest thing which we have done, one interesting thing which we have done is that we have introduced something called remote support system. So the remote support system is on each of the ships. This was in my last 2 years as the Chief of Materiel. So whenever a defect comes on board anywhere, so we can plug in that system to a device or the equipment which is called RSS, REST it is called, and the same system is there in the dockyards. So we can remote that system to the dockyards. So in case of defect, if the ship is not able to repair it, we can repair it from the dockyard. We can get the specialist there. He can take over the system from there and then change the software. Because as you know, now the ships have become more software intensive. And if the software gets corrupted, we can again load a new software there. If you want an upgrade, if a bug is there, we can debug it, all that. So that is one thing, because even our ships are now all over the world. You'll see a ship where near Australia, one is there in Europe, one is in the South China Sea, everywhere. So anytime they get stuck, we can get experts. We can get experts from the Navy, and we can get experts from outside also. Private industry, whether Bharat Electronics or a DRDO from NQL, and they can help us. So that is one thing which we have made it, and we have started using it. I read an article recently about a smart ship concept for in the US Navy. I think it was in the proceedings, where they are saying that in the future the ships will be very software intensive, like the cars are going to become. The cars now, you see, the software content is increasing. So you'll require software upgrades. If the upgrade is come or a new version has come, how do you send it to all the ships all around the world? So they also want something like this, but we already have it. So the system which we have now, we can upgrade the software. So these are the basic things. Anything else which you would like to know about technology? It's very interesting.
Not basic. Certainly not basic. And I can give you the assurance that after listening to you, the audience will certainly have a gamut of knowledge about the transformation that has happened in the Navy over the years. And the best part of it is that it is almost all indigenized modernization. So that is something we all Indians would actually cherish and admire looking at. And
So
since,
we are yeah. So,
yes,
so
please go
one thing
ahead,
which is, one thing very important is which we're looking at is combat management systems. So you know what is the combat management system on board a ship? What happens? We have different weapons and different sensors. So if a sensor finds there's an aircraft which is an enemy aircraft or an enemy warship, which weapon has to engage it? So that's why we have a combat management system. Right now, earlier we used to do it everything manually. Now we have a lot of inputs. Still, we have not made it fully auto that the weapon will be released, but we have it helps us in decision making, and then what to fire at which. So it gives us an optimum solution. Also, what has happened is we have now connected all our warships. So a warship which is ahead, which finds up an aircraft is there, but it doesn't have the weapon or missile which is there to get that aircraft down. So it can pass the information to a ship which is behind, and then that ship. So that network-centric operations is another thing which we are looking at, and we have really progressed quite a bit in that. Also, we can get inputs from a submarine. We can get an input from an aircraft, our aircrafts, and all this. It's called maritime domain awareness too, where the whole picture is available all around, and sometimes it can go to land also, and there they can give some inputs and get it back to us. So that is another interesting concept. Maritime domain awareness is a huge field because there are so many ships in our oceans which are maybe of merchant ships, maybe of other navies, to find out which is a friendly ship, which is not a friendly ship. That for that we need maritime domain awareness, and a lot of software is there, a lot of research has happened in that domain also.
So basically, to understand it simply for the audience, it's like all your assets, which are your ships and submarines, they are being viewed as collectively. And that is
Yeah,
being controlled through a central command and control, which is your maritime domain awareness system.
yeah.
I
That is
would, I
there,
would
and
like,
also we also using satellites now. No, our naval satellite also in the air, so we get pictures from the satellite. We also now, we have some unmanned aircraft we have bought,
Mhm.
drones we have bought. You would have read in the news from the US. So they also give us a picture. This whole picture is again analyzed, and it's all over the Indian Ocean. Our areas of interest. We keep mapping it, keep finding out vessels of interest, and then tracking them and finding out where are they going. Are they doing something which is against the nation? And then we can take action.
That's very interesting to know all this about the what Navy is doing these days. With so now you spoke about that everything is now very software intensive. So that brings on to my next question, that we have seen a lot of disruptive technologies available across the domains now, be it AI, Gen AI, quantum computing, and so on. So, do you see the use of these technologies also more as we progress further? Has the Navy charted its course for harnessing these technologies as well?
Yeah, there's no other way but to go in this field. If you see the lessons which we are getting from the two wars which are going on, one in Israel and the second between Russia and Ukraine, drones are being used in huge numbers. And it is very interesting that even civilians are able to use a drone.
Hmm.
So civilians are running drones. You know that we have been using drones for photography, etc. during weddings and otherwise in the US and all. You can buy a drone from Amazon and use it for your photography whenever you visit a place. So Ukraine has been using civilians for surveillance as far as drone is concerned, and drones are very economical, very cheap. And so in the Middle East or wherever mm, we feel that there is a threat of drones, we have to have an anti-drone system. So
Okay.
that is another thing which we are looking at. Because what happens is a drone is maybe some $1,000, etc. When you have to bring down, because you don't know that whether drone is carrying a missile, it's carrying some weapons. When you have to bring it down, you have to fire a missile at it, and a missile is $1 million. So after some time, if he fires 5 drones of $5,000, you finish 5 missiles of $5 million, you don't have any missile left. So that is another threat which is coming in. So do we use lasers? So we are working on that anti-drone system where you fire with the laser, or we have a sniper who can shoot down the drone. First, you have to direct a drone. So that is another thing which is going on. A lot of think tanks are studying it. We are also studying it. We have also started this thing of drone and anti-drone. Uh, Next thing is about uh, finding out, as I mentioned about maritime domain awareness. We are thinking of having some AI module where we find out exactly that which are the ones which are enemy ships, and if we start uh, finding out all the features of the parameters of the ship, what's because we generally know what radars they have, what frequencies are there, how does it look like in the optical side. With that, we should be 100% sure, because we can't make a mistake in this, because there are a lot of we have heard of mistakes being made in air where a civilian aircraft has been shot down. So that we can't make a mistake, because a lot of merchant ships, merchant marine in our oceans, and because all the 90% of the trade, as you know, is done by the sea. So again, we are trying to use AI for that. Then we have a lot of data inside of all our defects, etc. which have happened, and how was it resolved earlier? What are the ways it can be resolved? Again, we are using ChatGPT type of software to find a solution for that. Quantum, we are getting into it. We have a collaboration with the Raman Research Institute, this in Bangalore, which is doing a lot of work on quantums. We are right now concentrating on quantum communications and quantum cryptography. So these two fields are there, which are easier, and they will help us. Quantum sensing is a field which our research institutes will have to work on it, because if we have quantum sensing, we'll be able to find out submarines faster, and the detection of submarines is very, very difficult. So that will give us a foothold in finding out the latest technology and finding out where submarines are. So it's the various fields we are getting into as far as AI is concerned. We also have made a new center of AI in Bangalore. It's called Indian Naval Incubation Center for AI, INICAI. So this, when I was the CM, we did the inauguration. This was in January of 23. Now we have done. I had visited it recently. We've completed 2 years, and they've done a lot of work. So INS Surat, which was commissioned on 15th of January, is called a smart ship, because inside they made smart suites, and which the AI part has been done by INICAI. So a lot of good work has happened, and which will help us in long run. Yeah. But this again a work in progress, because these things are coming up. Disruptive technologies they have to come up. So we have to find out low cost disruptive technologies which will help us in the long run.
This brings me to the last question for this video. You mentioned about that, our people are not actually dependent on the technology. We have that readiness that if it is required, we may fall back to our old methods as well. But while driving this transformation, sir, did you face any resistance as such, or was it very easily adopted in the Navy?
No, nothing comes easy, because a lot of hard work. One is that driving tech, because that is not our primary work. Our primary work is to fight, to see that the ships sail and they're combat worthy in all respects. Developing new equipment, productionizing them is actually not our charter. But unfortunately for us, the nation was not ready. And so naval officers were deputed to various organizations. We made new organizations. One was, as I mentioned earlier, but VESI, and there was also one naval technical group. So this naval technical group is one which used to do, or still does, reliability and maintainability studies, and also makes the industry aware about it. We have one EMI AMC center, because this is another thing which is very important in warships, because we have so many antennas. So and inside also there are cables all around. So there's a lot of electromagnetic interference. So how should the antennas be placed? How do you remove this interference? So this is another new field as far as the industry was concerned. So we had to make that NEC or Naval EMI MC cell. Similarly, for the engineers, gas turbines was another thing which the country was not, marine gas turbines, the country had not encountered earlier. So we made a new establishment called INS Excella. We also made one software engineering group, where a lot of hardware and software codes, or even cards which were from Russia, which had become obsolete. So we learned how to get the new cards and ship the software there. So a lot of such work was done, and so because the industry, there was no one there, so we had to do it ourselves, and then we transferred it to the industry. And what I have observed, at least the sanskar of the Navy is such that we keep grooming young officers, and we have brilliant guys who are there, and there will be a lot of innovations in the future.
And one more thing to add to that is, sir, that as long as we have technology leaders like you, these challenges will not create a hindrance, and we certainly will make big leaps in the technology. So, sir, with that, I would like to close this interview for today. But before we wrap up, any message that you would like to share for this channel and for the audience?
Yeah. Well, thank you very much, Adip. And It's a privilege to be connected to the audience in this way. The only message I will give is that whatever I've seen, hard work is the key to success. There's no other way. So you have to work hard in whatever field you are, and then you will be, if you have worked hard for at least 10 years, maybe in pumps, in paints, in AI, in machine learning, in radars, every technology is important. Then you will be able to innovate in the 11th year, 12th year. But hard work you have to do. And that's what is our sanskar in the Navy, and we have all been doing that. Thank you so much, Adip. Thank you.
Thank you, sir. It was indeed an honor and a privilege to have you here with us today.
Thank
you,
you.
sir.
Bye.